We are ready to dig into the concept of JavaScript time, and we're just going to scratch the surface with the simplest command, getTime. And to see what that's all about, we can read the documentation, and we'll find out that it gets the number of milliseconds elapsed since January 1st, 1970. So time on a computer is calculated from the number of milliseconds elapsed since January 1st, 1970 at midnight. And every computer has a counter that keeps track of these milliseconds. So AppLab does too. Your Chrome browser does too. So let's say var time equals getTime, and let's see what this thing does. I've created a label, so we'll just set text of that label to the result of our getTime call, which we stored in time, and we'll show that on the screen. And that's this big long number, and I think that's in trillions. So it's a number. We can count it, but we have to convert it to a string first. So let's say time equals, how are we going to convert a number to a string? We can just say time dot toString, and that converts a number to a string. So now time is a string, and then we can just say find out the size of that string, because every string we can just do dot length, and that tells us the size of the string, and we'll just log that to the console. So when we run it, we find that that's the number of milliseconds since January 1st, 1970, and that's 13 digits. So that's trillions. That's 1.5 trillion milliseconds since January 1st, 1970. We can play around with this. We could use this as a timer. So let's say that we have, we want to start. We'll get the time, and then we want to var end, and we'll get the time at the end. And let's just count how long it takes JavaScript to count to 100. So I equals 1. We're creating a for loop, so not a var loop, but we're going to create a for loop, and we're going to start our counter at I equals 1. And we're going to go until I is less than or equal to 100. And we're going to increment I each time through the loop. And so then we're not going to do anything in the loop, but we're going to just start and end. And then let's just say var time equals end minus start. So we're just going to basically start is going to get us a time, and end is going to get us a time, and we're going to subtract them, and that's going to tell us the number of milliseconds that have passed. And we'll just show that up on label 1. So we'll show that time up on label 1. So for var I equals 1, we got to say var I equals 1. I is less than or equal to 100. I plus plus. That's a proper for loop. Now it's going to work. So we start, loop to 100, we end, and then we see how long it took, and then we show that on the screen. So it took 3 milliseconds. So it's very quick. JavaScript is extremely quick at counting in its head. What if we make it log to the console? So what if we make it count out loud? And it has to log I to the console. Does that slow it down? So we reset, run. It counts. Yeah, it took half a second once we log it to the console. Yeah. What about counting to 1,000? Is that going to add significantly? So we reset, run. Oh yeah, that's taking some real time. It is taking JavaScript a long time to count out loud to 1,000. Very surprising that it's that slow. 13 seconds. So what if it's just counting in its head to 1,000? In other words, we're not going to log to the console. We're just going to do it. 17 milliseconds. Wow, okay, so this is telling us that logging out to the console takes significant time. What if we count to not 1,000, but 10,000, 100,000? Let's count to 1,000,000. How long does it take a for loop to run through 1,000,000 iterations of a for loop? It's still going. I'm going to say it's going to be under 20 seconds. And it is not done yet. 11.4 seconds for this for loop to run through 1,000,000 times. So that's pretty quick. But anyway, that is time. So you can just play with those milliseconds and have all kinds of fun setting timers. Start, get time, then end, get time, and then subtract the 2 times. And you have the number of milliseconds that have elapsed since the start and the end. And this is the end.